Okay, hello. This is Mr. Radmore. This is a quick video. Okay, hello. This is Mr. Radmore. This is a quick video to run through how Year 7 and 8 students can log on to Tassamy. So if you open up your web browser and then go to just search for the Tassamy website. Should take you straight there. Oh. Got there eventually. Just click on first search results. And then if you go to the top right hand corner and sign in. Now you won't have a login yet, so you need to go to the option down here which is register with a code. Now I will send an email with the code and put the code on show my homework as well. The code is TGPXQ8AM. So that's the code that I will email and put on show my homework. Then press next. Then it will ask you for your details. So if I do a random name, we'll do John Smith. And you will need to put your email address in. So that will be your user ID. That's the user ID that you use to log into the school system at cset.co.uk. So your user ID to log in at cset.co.uk. Then you need to create a password. I suggest just the word password would be a good idea. And then it will ask you to select your form from the following list. So if you click on that, what you need to do, scroll, huge list of classes come up, scroll down, and then pick either Year 8 for a Year 8 student or Year 7 for a Year 7 student. I'm going to pick Year 7 because our fictional student, John Smith, is in Year 7. Then press Submit. Okay, so then you're logged into Tassamy. Now we're going to use this for science because maths and English are using different online platforms for homework. And then you are taken straight into it. Now the way Tassamy works is you've got quizzes that will come up and you need to complete your daily goal, which will be up to about 40 questions. But the more you do, here we're starting on 20, and the more you do it, the more the daily goal will decrease as well. Now also you can have a look and see how well you've done by pressing Analyze, and this will bring up lots of data to do with the questions that have been answered over 7 days, 30 days over all time. And the dashboard, like I said, takes you back to the subjects, but we're just sticking to maths with that case. So once you click a science topic to quiz yourself on, okay, you can skip that for now, and it takes you straight to the multiple choice quiz. And for example, here, look, butter contains mostly fat, and it will take you through multiple choice question after multiple choice question. Okay, and more information will follow in the form of emails. Thank you very much.
Good morning, Year 7 Mangotsville students, Mr. Cruzy here. That was Mr. Radmore's video about how to log into Tassamy. If you haven't given Tassamy a go yet, then it's a good idea to have a look at that. You can find Mr. Radmore's video on our YouTube channel and have a look at how you can log into Tassamai. It's a general science quizzing program, quizzes you on everything from year 7 and year 8. So that was a quick information video about Tassamai. Good morning. Hope everyone's doing all right today. It's Thursday, obviously, week 2 of term. Week 2? It is week 2. I have to remind myself of that sometimes. And we are going to be doing Earth Lesson 4 today. And we are going to be moving on to look at the Earth's atmosphere and some of the products and useful gases we can get from the Earth's atmosphere. Before we do that, there is a starter up on the screen. So whilst we're waiting for this lesson to begin at 10:15, have a go. There's 10 questions. You don't have to write them down, but just decide for each one whether the answer is A, B or C. And I've already had a couple of emails this morning. Always really good to hear from you, Mancasville students. And our first shout of the day is for Rodway. Get in there, Rodway. Rodway House. On the live stream for Mancasville Year 7 Science students. Well done, Rodway. So if your name begins with C, big shout out to Rodway House. Okay. And yeah, if you're not sure how to contact me, if this is your first time on the live stream, welcome. Good morning to everybody. And you can get in touch with me if you've got a question, if you get stuck on something, if you need me to slow down or speed up, then you can get in touch by emailing me on your school email account. If you open your school email, you will have an email from me about this live stream. You can click reply, send me an email, and I've got it open. My email, my official school email is open in front of me here, so I can see your messages, whether that's a shout out for your mental group. I can't see anybody's name individually, unfortunately, because we have various rules about that with sort of things in school, like safeguarding and data protection. But I can give shout outs to mental groups. I can certainly answer questions if you get stuck about anything. And that's one of the really good things about this live stream, is that you can get in touch with me during the lesson. I'm here live in my home with my daughter. I can hear her running up and down outside on the landing. And yeah, we're going to go through lesson 4 today, and that will start at 10:15. So in the meantime, whilst you're waiting, have a go at the starter quiz. You don't have to write it down. Just think to yourself, for each question 1 to 10, is the answer A, B, C or D? If your name starts with M, a very good morning to you too. And a big shout out to Pomfrey 7.2. Good morning. Good morning to you all, and big shout out to Pomfrey House and Pomfrey 7.2. Very good to have you on the live stream. Well done for joining in this morning. Well done for being ready to do your science work today. And I'm going to be taking you through lesson 4, and we're going to get started at 10:15. So in the meantime, please do have a quick go at the quiz on the screen. My daughter is tiptoeing past the room because she's trying not to interrupt. She's a good girl. She's a good girl. But yeah, we are here. We are live right now, ready to do lesson 4 in a few minutes' time. And it has been really good to hear from you, Mancasville Year 7 students. Got another shout out coming in for Rodway 7.1. Second shout out for Rodway. So thank you, person whose name starts with C. Give me 2 shout outs this morning, which is great. Shout out to you for Rodway House, and in particular for Rodway 7.1 Mentor Group. Big, very big good morning to you. Hope you're all doing okay out there, whether you're in Rodway or Pomfrey or Chase or Syston. Very good morning to all of you, Year 7. Really good to have you along on the live stream, and a big shout out to Rodway, and in particular Rodway 7.1. Okay, so we're going to get started at 10:15, so 5 or 6 minutes time. In the meantime, have a look at the quiz. You don't have to write it down. Just try and quiz yourself on the last couple of lessons. So we've learned so far about the Earth's structure, the crust, the mantle, the inner core and the outer core. We have learned about the rocks in the Earth's crust. So this quiz is about that. And here we go. If your name starts with O, a really big shout out to you, and a big shout out to Chase 7.1 Mentor Group. Very good morning to you. Really good to get a shout out for Chase as well. So yeah, Chase House, if you're in Chase House and you're with us on the live stream this morning, very good morning. And in particular, Chase 7.1, big shout out to you. And please do remember, as we go through the lesson, you can email me questions. I can do more shout outs as we go along. And if there's anything you get stuck on, if you want me to tell me that you're done, or if you feel like I'm going too fast, just let me know. We're going to do the Earth's atmosphere today, the gases in the air, and what useful products we can get from that. And I'm going to go through this starter in about another minute or two. In fact, let's just put a minute on the clock. 1 minute to finish off this quiz. You don't have to write it down. Just think to yourself what you think the answers are, and then we'll go through the answers. Yeah, so if you're just joining us, we are going to go through the answers to this starter quiz. You don't have to write this down. But if you are just joining us, a very good morning to everybody. And yeah, if your name starts with M, if you've got the initials MS, a very big shout out to you this morning. Thank you for your message. It's really good to hear from you. It's really good to know you're joining in with the live stream. Very good morning to everybody. And yeah, big well done to Year 7 Mancasfield students for being on the live stream, ready to do this science lesson today. We are going to get started very soon. And so yeah, let's have a look at this starter quiz. Let's go through the answers. All right, here we go. Granite is an igneous rock. Limestone is sedimentary. Marble is a metamorphic rock. Sedimentary rock contains layers, so 4 is sedimentary. Number 5 is igneous rock. Igneous rock is made of crystals. Number 6, metamorphic rock contains distorted crystals or distorted layers. And metamorphic rock can be made by heat and pressure deep in the crust. Igneous rock is made when hot magma cools down and solidifies. And sedimentary rock contains fossils. If you said metamorphic, that would be a decent answer as well. Metamorphic can sometimes contain distorted fossils, but igneous rock never contains fossils because it's made of hot magma. Any bones or skeletons or shell creatures, any remains would just get melted by the hot magma. So igneous rock never contains fossils. Okay, we're going to get this lesson started very soon in about 2 or 3 minutes time. So well done if you were joining in with the starter quiz. Hope you got 10 out of 10, but if whatever you got, if you got 7 out of 10 or 8 out of 10 or 6 out of 10, well done for quizzing yourself. It is quite normal to start forgetting things, especially when you're doing lots of different lessons and lots of different subjects. So one of the reasons for doing some quizzes sometimes is to help you keep some of these facts in your memory as time goes by. Okay, yeah, right. In fact, on the subject of quizzes, please do remember after the lesson that each lesson that we're doing also has a Show My Homework quiz. You can find those by going back to Show My Homework and clicking on the entry for either lesson 3 or lesson 4, and there's a 10-question quiz to do. So please do remember, as well as doing these lessons, to go back onto Show My Homework and look for the entry for Year 7 Science, lesson 3, lesson 4, because there are Show My Homework quizzes to do. And that's another way of quizzing yourself, testing yourself, to check you understand the work, and we're keeping track of that as well, so we can tell more clearly if Year 7 are understanding the topic that we're doing. So it's really helpful if you can do those quizzes. And yeah, we're going to get started with lesson 4. And just to remind you, if you're joining the live stream for the first time, that there's no live comments on this live stream, but you can email me by opening your school email account, finding an email from me about this live stream. You can reply and I can read your messages here in front of me on my school email account. A couple of the messages I've had for previous lessons have been about written work. And just to remind you, you don't need to write anything down until we get to the part of the lesson which has orange, green, yellow, blue on the screen, and that's the main writing task. For that part of the lesson, you will need pen, paper or exercise book, or possibly a Word document, because there will be written work at that part of the lesson. You don't have to write things down until we get to that orange, green, yellow, blue section. Just to quickly show you, here's one example of a Year 8 book where somebody has put their driving question and they have written their answers in full sentences, and they've even sort of labelled in the margin what each bit is to help them remember what they've done, and it also helps them to decide at the end of the lesson, today I achieved. They can tell really clearly what they've achieved because they've sort of organised their work like that. But the most important thing is to write in full sentences so that you are explaining the science in your own words. So that's a really important way of telling if you understand it. And then when we go through the answers at the end of the lesson, you'll be able to tick things that you get right and feel really good about that, and then make improvements where needed, and that helps you to keep improving at science. And I know that loads of you have done fantastic work so far on this topic. I've seen and heard a few emails about your work from you, which is brilliant. And just a big well done, Year 7, for taking responsibility for your learning, for getting these lessons done from the safety of your own home. And we are going to get started on today's lesson. Earth topic lesson 4. Here we go. Right, yes, so the Earth gives us natural resources. Today we're going to look at the atmosphere and the air, and we're going to see how we can use chemistry to turn natural resources into useful products. So today, what useful products can we get from the air, and what is air made of in the first place, and how can we use or what substances can we get from the air which might be useful. Along the way, we are going to revise the words mixture, element and compound, which is something that you all learnt about earlier in the year. So here we go with lesson 4, driving question, what is air made of? That driving question will reappear later so you can write it down. Okay, so what is the air made of? What gases are in the air? Well, let's imagine a space shuttle taking off from Earth, and it's going to travel through the air, through the Earth's atmosphere and out into space. What would it travel through? Right, now let's have a look at this diagram. Oh, I've clicked on the wrong thing. Apologies for that. Back to the show. Right, we go. There we go. Right, back on track. And here's a diagram of the different sections of the Earth's atmosphere. Right, now I just want to point out, so a space shuttle would fly really high. Okay, about 350 kilometers. A plane flies here about sort of 6 to 20 kilometers. Right down at the bottom of the diagram is Mount Everest, the tallest mountain on Earth. So you can see how small that is compared to the Earth's atmosphere. Now the Earth's atmosphere is made of air, and it's made of air all the way through. But as we go higher and further from the Earth, the air gets thinner and thinner and thinner. There is an ozone layer. Now it's still made of air, but it contains a little bit more ozone than usual. And the ozone in that part of the atmosphere helps to protect us from ultraviolet radiation from the sun. But it's still made of air. There's just a bit more ozone in that part of the atmosphere than in other parts. And as we go up, the air gets thinner and thinner and thinner. Now, there's no sort of hard boundary where the Earth's atmosphere ends. Okay, it just gets thinner and thinner and thinner until there's no air left anymore. So it doesn't have like a definite stop where it's like, oh right, that's where the atmosphere ended. It just gets gradually thinner and thinner, right? And all the way up, it's made of a mixture of gases, but it just gets thinner and thinner until there's no air left, and that's where we say outer space starts. So what gases are mixed together in air? Well, let's have a look at this experiment. Here's an experiment to find out what air is made of, and it makes use of a substance called liquid nitrogen. Now, liquid nitrogen is amazingly cold. It is like minus 200 degrees. Okay, here is nitrogen as a gas. It's a colourless gas, and if you put a wooden splint into nitrogen, it goes out straight away. Nitrogen is unreactive. It's an unreactive gas. Okay, but if you cool it down to a liquid, liquid nitrogen is liquid at about minus 200 degrees, and it is so cold it will freeze things absolutely instantly. So here's a flour going into the liquid nitrogen, and it turns solid. It just instantly turns solid because that is so cold, minus 200. Right, so they can just crush it because liquid nitrogen is really, really cold. Okay, instantly freezes things. Now, in this experiment, what they've got is a boiling tube full of air. There's only air in that boiling tube, but they are dipping it into a beaker of liquid nitrogen. So that is minus 200. So this air in this tube, that's all there is, it's only air, is getting cooled down to minus 200. And what happens is the air itself turns to liquid. So that there is liquid air at minus 200 degrees. Now, in this experiment, the liquid air is allowed to warm back up. And as it warms back up, the gases in the mixture, well, the chemicals in the mixture turn back into gas. So the first gas that comes off is unreactive. It is nitrogen. So air contains nitrogen gas, right? But then the second gas that comes off will make the wooden splint burn. That's oxygen. So there's oxygen in the mixture, right? So what this tells us is that air contains a mixture of nitrogen and oxygen. Here's the oxygen making the wooden splint burn. Okay, so this experiment is used to separate the gases in air. They cool it down to minus 200 degrees, okay, and there's a mixture of chemicals in air. They cool it down to minus 200 degrees, then they let it warm back up again. And as it warms back up again, it separates into the different gases. Right, now it does that because the gases have different boiling points. Nitrogen boils at a slightly different temperature to oxygen. So the nitrogen turns to gas first, then the oxygen turns to gas second. Okay, now this is quite complicated. This is the hardest thing in this lesson, right? We're doing the hard bit, the blue bit, straight away today. So don't worry if you think this sounds complicated. It is, we're going to go through it a little bit step by step, right? So just to repeat, we take air, cool it down to minus 200. The air turns to liquid, right? Now the mixture is allowed to warm back up again. As it warms back up again, the chemicals turn back into gas. Nitrogen first, then oxygen. And that's because they have slightly different boiling points. Now nitrogen boils first because it's got a slightly lower boiling point. Okay, now this technique is called distillation. I'll say that again in just a moment. Let's go through it one more time because this is really difficult. The test tube contains air. Right, so they cool it down to minus 200. The air turns to liquid. Okay, so the air condenses to make liquid at minus 200. They allow the liquid air to warm back up again. Now when it gets from minus 200 to minus 197, so even though it just warms slightly, the nitrogen boils and turns back to gas. So nitrogen is produced first. Then, when it gets a little bit warmer again, oxygen will turn to gas, and then oxygen can be collected at about minus 180 degrees. Okay, so take air, cool it down to a liquid, allow it to warm back up again. Nitrogen turns back into a gas first, oxygen turns back into a gas second, then we can collect nitrogen and oxygen. Now, let's see how much of that you could understand. I've taken that explanation, this is like the blue explanation where we're combining difficult ideas together, and I've jumbled it up. So can you put it back into order? So I'm going to put 2 minutes on this clock, and can you, in fact slightly longer, let's do 2 minutes 20, and can you read through the sentences? Can you put it back into the right order? Okay, so this is the hardest thing in this lesson, right? We're doing the hard bit straight away today. Can you put these sentences in order? You don't have to write it down. You don't have to copy it. Just try and, you might want to jot down the letters to help you keep track of your answer. Can you work out what the start of the answer is? Can you put them in order? Which comes first? Is it A, B, C, D, E, F, or G, or H? This is really difficult, right? But see if you can think about it really carefully and put the letters in order. Yeah, just whilst you're doing this question, got my sound back on now. If your name starts with S and you sent me a question about Tassamai, do we need to download that Tassamai that I was talking about earlier in the lesson? You can either download it as an app to your phone, or you can do it through the website, or you can do it on a computer through a website. So yeah, you can download it. That's the easiest way to do Tassamai, is to quiz it on your phone using the app. But you can do it through a website, either the browser on your phone or the browser on your computer. But yeah, thank you for your question. Great question about Tassamai. Right, so can you put these sentences in order? This is the hardest part of this lesson today. We're doing it straight away. How much of it can you understand? Can you work out what order these sentences go in? Yeah, and another shout out if your name starts with C. Third shout out today, which is great. Thanks for your emails. Can you shout out Rodway and Rodway 7.1? I try not to be too biased towards different houses, but I used to be a Rodway mentor, so I like Rodway. I'm not saying I don't like the other houses. I like all the houses, but go on, Rodway. Really good to hear from you as well if you're in Pomfrey or Sison or Chase. I'm not biased. Not too much. Right, okay, now let's go through the answers. So firstly, the first step is E. Air is cooled until it becomes a liquid. And then C. The liquid is allowed to warm up again. F. Nitrogen turns into a gas first. D. Because it has the lowest boiling point. And then G. Pure nitrogen is collected. Then what happens after that is B. Oxygen turns into a gas second. And then H. Because it has the next lowest boiling point. Then A. The last thing is pure oxygen can be collected. Now if you are understanding that and getting that right, that is fantastic, because this is the difficult part of this lesson, combining difficult ideas together. We've got gases, we've got mixture, we've got boiling points. When we get to the writing task, that's going to be like the blue question, combining difficult ideas together. So if you're managing to understand that, fantastic. Just before we get going on the next part of the lesson, another question about tassomy. How do you know you have completed your tassomy? Well, tassomy, we've said that tassomy is a really good thing to try if you're in year 7 and year 8. So if you can get on the website or the app and give it a go, that is fantastic. Tassomy will tell you on the website or the app, once you log in and make an account, if you've done your daily goal. Right now, a daily goal to start off with is about 30 questions. It's like multiple choice. You go A, B, C, D, and it'll count down. It'll tell you if you've done your daily goal. So we're recommending year 7s and 8s to try and do one daily goal. Just give it a try it out. So how do you know if you've completed your tassomy? If you've done a daily goal on tassomy, because you've done like 30 questions or whatever it tells you your daily goal is, then that means you've done your tassomy. With the daily goal on tassomy, the more often you do it, the number of questions it requires goes down. So the daily goal gets easier the more that you practice it. But yeah, well done for asking me about tassomy. I did play a little tassomy video at the start of this live stream, and it is a really good thing to be doing in amongst the other things that you're doing at home as well. Right, let's get back to the Earth's atmosphere and these gases. Now we know that nitrogen is in the air, oxygen is in the air, but how much? Right, now it turns out that air is mostly nitrogen. About 78% of air is made of nitrogen gas. Oxygen makes up around 20 to 21%. Sometimes you'll see it written as 19% or 20% or 21%. It's not exact because it slightly varies in different parts of the atmosphere, but it's always roughly around 20% oxygen. Now there are a few other gases in the air. You might not have heard of this. Argon gas is 1% of the air. Now argon gas is another unreactive gas, a bit like nitrogen, and it used to be used inside light bulbs. It's not really used anymore because light bulbs have improved. Now we've got energy efficient light bulbs, but we can still make use of argon, not Argos. Did I just say Argos? It's not the shop. It's not the shop fry. It's called argon gas. It's in group 0, group 8 of the periodic table. It's called a noble gas, and it is unreactive, and it makes up 1% of the atmosphere. And yeah, carbon dioxide. We're going to talk a lot more about carbon dioxide later in this topic when we look at global warming and climate change. Carbon dioxide makes up 0.04% of the atmosphere. Sometimes people go, I was expecting it to be more than that because we hear about that in the news with global warming and things like that. But you've got to imagine how massive the Earth's atmosphere is. 0.4% of something massive is still a lot. And if that only goes up by a little bit, it has a big effect on our climate. Right? So if carbon dioxide went up from 0.04 to 0.05, that would be a huge issue for us in the Earth, right? And we're going to look more at carbon dioxide and global warming later in the topic. For now, how much of each gas is in the air? Nitrogen, just under 80%, around 78%. Oxygen, around 20%. Argon, 1%. Carbon dioxide, 0.04%. Other gases includes things like water vapor and also helium, like for balloons. That's a really tiny amount of air. That's about 0.001%. So there are some other gases mixed in, but it's mostly nitrogen, oxygen, 1% argon, 0.04% carbon dioxide. Okay, and let's look at the chemical formula of those gases. Nitrogen has the formula N2. Oxygen, hopefully you'll have come across this before, is O2. Argon has the symbol Ar. Carbon dioxide is CO2. Water vapour, H2O for water, and it varies. Now, these gases are mixed together in the air. Here is a diagram showing the molecules. A molecule is a small group of atoms. So here we go. Nitrogen is N2 because it has 2 nitrogen atoms bonded together. Oxygen is O2 because it has 2 oxygen atoms bonded together. Carbon dioxide, CO2, 1 carbon, 2 oxygens, CO2. Argon isn't bonded to anything, so it's just got the symbol Ar. And then water's up there, H2O. 2 H's, 1 O, H2O. Right, so they have a chemical formula based on what atoms are in their molecules, and they are all mixed together in air. So air is a mixture of these different chemicals. Right, now a mixture is a collection of substances that can be easily separated. Okay, and the chemicals in the mixture can be classified as elements or compounds. Right, so a mixture is a substance or a collection of substances that can be easily separated into more than one substance. So air is definitely a mixture because it's got more than one substance that can be easily separated. And each gas in the mixture is an element or a compound. Now, elements and compounds is something we learnt about in the first chemistry topic of the year. So that was a while ago, so we might need to just revise that quickly. Right, so air is known as a mixture of elements and compounds. It's a mixture because it can be separated into different substances, and the substances in it are elements and compounds. Let's remind ourselves what those words mean. An element is made of one type of atom only, whereas a compound is made of more than one type of atom bonded together. Right, so element, one type of atom only in that chemical. Compound, more than one type of atom bonded together. Air is a mixture of elements and compounds. Now, which one is which? Now, we're going to go through this one at a time. And for each chemical that appears, can you please say, or just say to yourself, or think to yourself, is it an element or is it a compound? Is it made of more than one type of atom bonded together? Then it's a compound. If it's just one type of atom, it's an element. So let's have a look. Nitrogen gas, N2. What do you reckon? Do you think it's element or compound? I will tell you, hopefully you've had a chance to think about it. Just going to pause. It's got one type of atom only. It's an element, right? Nitrogen gas, N2, is an element made of one type of atom only. What about oxygen? I'm going to pause for 5 seconds whilst you have a think about it. Element or compound? And it's got one type of atom in it only one type of atom, so it is an element. Right, let's see, what's the next one coming up? Carbon dioxide, element or compound? It is a compound, more than one type of atom bonded together. It's got carbon, it's got oxygen, more than one type of atom bonded together is a compound. Next, water, H2O. What do you reckon? Oh, it's come up already. Oh, hello, got some timings on this. Right, let's go back. So water is a compound because it's got more than one type of atom bonded together. And the final one, argon. What do you reckon? Element or compound? One type of atom only means it is an element. Okay, so air is a mixture of elements and compounds. The elements are made of one type of atom, and you can see that in their chemical formula, right? N, there's only one type of atom. There's 2 inside the molecule bonded together, but only one type of atom. N2, O2, Ar are all elements. Compounds, more than one type of atom bonded together. We can see that in their chemical formula. Carbon and oxygen bonded together. Hydrogen and oxygen bonded together. Please remember that elements or types of atoms start with a capital letter. So if you see a capital C and capital O, that's two types, carbon and oxygen. If you saw capital C and a little o, that would actually be cobalt, which is one type of atom. So if it's capital letter, that is the start of a new type of atom. Right, so compounds, more than one type of atom bonded together. Air is a mixture of elements and compounds. Right, let's pause this for 1 minute. Can you get the definitions matched up correctly? Which is element, which is compound, which is mixture? Don't have to write it down, don't have to copy it, just match the letters and numbers. Go for it. I keep looking to the side so I can hear my daughter. It's checking if she's okay. We are live in my house. I think she's alright. I think she's okay. Hello. Hang on. Right, we are going to go through the answers to these definitions. Oh, there we go. Here we go. Which one is which? Right, so 1 was B. A mixture can be easily separated. 3 was A. A compound contains more than one type of atom bonded together. 2 was C. A chemical made of one type of atom only is an element. Okay, so hopefully now we're familiar with these definitions. And we're going to make use of these definitions. Think to yourself, you don't have to write it, but if there's somebody in the room, it's a really good idea to tell them your answer, see if it makes sense when you say it out loud, or just think it to yourself. Why is air known as a mixture of elements and compounds? Can you put it in words for yourself? Can you come up with a sentence in your mind, or say it out loud to somebody in the room? I know sometimes some of you have brothers or sisters hanging around, some of you might have your parents nearby. Feel free to say your answer out loud. If you can say it out loud and it makes sense, then that's a really good sign that you understand it. So why is air known as a mixture of elements and compounds? Right, okay. Yeah, that was my daughter. She's just putting in her lunch order with me. She's getting hungry already. It's not even lunchtime yet. Right, okay, here we go. Right, what was your answer? What did I say? I said, why is air known as a mixture of elements and compounds? Air is a mixture because it can be separated into more than one substance. In the mixture are elements and compounds. For example, nitrogen, oxygen, argon are elements because they're made of one type of atom. Carbon dioxide and water are compounds because they're made of more than one type of atom. They are mixed together in air, and air can be separated into elements and compounds. When we do this in a minute for the writing task, then try and make sure in your answer you include the meaning of the word mixture. It can be easily separated. The meaning of the word element and the meaning of the word compound. To try and use those meanings in your answer. Okay, right, one final question before we do the writing task. Have a read through the screen. Is the correct answer A, B, C or D? Right, if your name starts with M and you emailed me your answer to the last one, you got it right. Thank you for emailing me. I didn't quite manage to read that out in time. Apologies for that, but you did get it right. Fantastic. Well done. Always really good to know that you're out there on the live stream. I really like reading your emails and knowing that you're following along, getting answers correct. If you sometimes don't get them correct, that is fine too. We learn just as much from correcting our answers as we do from doing them in the first place. I had a really good question earlier about whether the gases add up to 100% or not, and I'm going to answer that in just a minute. So I have read that question, and I'm going to answer it just before we start the writing task. Thank you for that email. It's a really good question about is it 100%. Okay, right. Now, which is the correct answer? Oh, I haven't put it in. Right, let's think through it. So, they can both be made of molecules, or they can both, elements are sometimes molecules, sometimes not. Compounds can be molecules, or sometimes they can be giant structures. Molecule is slightly different points. It's not A. B, is B correct? Made of one atom, made of more than one atom. It's true, but it doesn't say bonded together, so it's not the best answer. Let's read the other ones. One type of atom bonded together, so that's a bit better. D is the best answer, right? B, C, and D are all technically correct, I think. One type of atom, more than one type of atom. Oh no, D is wrong. Hang on, take that back. Didn't read it properly. It is C. C is the correct answer. Elements are made of one type of atom. Compounds are made of more than one type of atom bonded together. Alright, so D is incorrect because it's the wrong way around. B is on the right track, but it misses out the idea of bonding together. A is about something different. Molecules is a slightly different idea. So C is definitely the correct answer. Elements made of one type of atom. Compounds made of more than one type of atom bonded together. Right, it is time for the writing task. So this is where you need to write the driving question at the top of your work, and then we're going to work our way through orange, green, yellow and blue. That means describing facts and key words. It means summarising the main point of the lesson, using it to explain the situation in more detail and combining together difficult ideas. Now what I would suggest for orange and green is actually doing a little table like this with the gas, the chemical formula, and can you remember how much of the Earth's atmosphere it was? Now, I had a question earlier, does it add up to 100%? It looks like on the diagram it goes over 100%. Now, the gases in the Earth's atmosphere, they can vary. Nitrogen is sometimes 78%, sometimes 79%. Oxygen can sometimes be 19 or 20 or 21%. Argon is always around about 1%. Carbon dioxide is always about 0.04%. The other gases, which you don't need to write into this, right, we're looking for nitrogen, oxygen, carbon dioxide and argon. The other gases like water vapor varies quite a lot. So depending on what source of information you look at, you might see slightly different values for the percentages of the gases, but it will add up to 100%. If you take a sample of the air, it will add up to 100%. But if you take information from more than one source, the sources might vary slightly to each other because they've taken different samples of air, and there's a little bit of a leeway in terms of exactly how much it is. Right. So yes, this is a bit of a memory test, right? So the four gases you're looking for, let's put a timer on. The four gases you're looking for are wrong timer. Nitrogen, oxygen, carbon dioxide, argon, not necessarily in that order. Can you remember what their chemical formula was? Can you remember what percent of the Earth's atmosphere was? That is the orange and green part of this lesson in this table up here. You don't have to write out all the lines. You could just write a subheading, like you can write it in sentences instead if you want to. How you lay it out is up to you. But the idea for orange and green in this lesson, the knowledge and the main bit of understanding is, what is that gas? What's its name? What's its chemical formula? How much of the Earth's atmosphere is made of that gas? Right, and if you've forgotten, I can say it again. You can send me the email and go, I can't remember how much was argon, or I can't remember what the formula of nitrogen was, and I can say it again. But I'm not going to say it continuously because I want to see if you can sort of remember it from earlier in the lesson. Right, if your name starts with M, thank you very much for that email. Really nice message, and big shout out to Pomfrey 7.2. Pomfrey on the shout outs. If you're in Pomfrey House, or in particular Pomfrey 7.2, big shout out to you today. It is really good to have lots of year 7s along on the live stream. Obviously I can't see you or hear you because it's not like a two-way thing, but it's really good to read your emails, really good to get your questions, really good to be able to give a couple of shout outs. And it's a really nice thing about the live stream is to know that there are other year 7s just like you in their own houses doing this lesson at the same time that you are. And it just goes to show Macclesfield Science students are brilliant. Not an easy situation to be stuck at home the whole time, and you're doing the right things you are getting your science work done, especially with this part of the lesson where we write it in sentences, or in this case in a little table or in little columns. Really good to know that you're all doing so well on your science work. Mangotsville students, brilliant. So the four gases are nitrogen, oxygen, argon, carbon dioxide. Can you remember what their chemical formula was? Can you remember how much of the atmosphere they are? Yeah, right. Really good question about this kind of grid on the screen. How does that relate to working towards or working at? It's kind of mixed together. The orange is remembering the chemical formula of the gases, right? The green is the percentage of the Earth's atmosphere and summarising that. Okay, so I probably should have put a little orange symbol. Oh, what's the mouse gone? Can I get pointer options? Pen. Right. If I just do a little working T here. Right, so the facts, orange, describe, is about describing facts and keywords. In this case, the names and formula of the gases. The main understanding for this lesson is what is the percentage in the Earth's atmosphere. So you could write a sentence, nitrogen gas has the formula and it is percent of the Earth's atmosphere. You could write it out in sentences if you want to. I thought it might be quicker if you just did a little list or little columns, but how you lay it out is totally up to you. But yeah, to answer your question, if your name starts with E, great question. What is the working towards task? I don't always think of them as separate tasks. Sometimes it's about realising that orange means facts and keywords. Green means the correct science understanding. And the correct understanding for this lesson is how much of each gas is in the atmosphere. But the factual bit is what is the chemical formula of each gas and what's its name. So if you'd rather write that in sentences, go for it. That's absolutely fine. If you want to do it separately and go, nitrogen is oxygen has the formula and then go back through and go, nitrogen is percent of the atmosphere. I'm going to stop making that noise now. It's probably getting annoying, isn't it? How you lay it out is up to you. I probably should have put a little orange symbol up here somewhere, and I probably should have put a little green symbol up here somewhere. Hope that helps. Great question. Thank you for emailing in your question. Can you explain or go through green and orange? Yeah, okay. Yeah, bit of a memory test. So I'll just go through some. Yeah, well done if you've managed to remember it and written it down already. This will help you to check if you're on the right track. If you can't remember, here we go. Right, so the first one is nitrogen, and it has the formula N2, capital N, little 2. Let me get the pen back again. My writing's going to be terrible now, but let's give it a go anyway. Right. Oh, nitrogen. That's actually readable. I'm surprised. Right, and it has a chemical formula N2. I should probably have put a bit more of sort of memory quiz on this earlier in the lesson. Right, and then, oh, that's going to be too big. Never mind, I've started now, carry on. Oxygen. Okay, right, and its chemical formula, I'm going to leave that blank. Hopefully you know the formula of oxygen. If not, maybe you can have a guess. And then the other one was argon. This will help you with spellings as well. Right, and that is capital A, then a small r. And then, oh, how am I going to fit this in the box? Carbon dioxide. I have to write smaller. Right, so this is the working towards for this lesson. It's remembering these names and what their formulas are. Carbon dioxide. I'm just about managing to write this. Right, and I'm going to leave that one blank as well. See if you can remember the formula of carbon dioxide. Then, can you remember what percentage of the Earth's atmosphere is each gas? Right, one of them was 1%, one of them was around 20%, one of them was around 78%, one of them was around 0.4%. Which one was which? And yeah, just a question about what is a chemical formula. A chemical formula is when we use symbols to say what atoms are in each chemical. So nitrogen, we use the symbol capital N for nitrogen, and there are 2 nitrogen atoms bonded together inside every particle, so it has a formula N2. Now that's something that we did in one of the first topics of the year. So it was a while ago now, so a lot of people will have forgotten that. So part of the reason for doing this lesson like this is to try and bring back ideas like chemical formula, element, compound, mixture, things that you learnt about earlier in the year, and it helps to revise it, but we're also putting it into a new situation because we're looking at it in terms of the air and the Earth's atmosphere. And it is normal to forget things. Everybody forgets things. Memory decreases over time, and that's why it's a really good idea for us to try to bring back old things during new topics to help you either remember it or learn it again if you didn't get it the first time. So please do keep emailing if there's something you're not sure of. It's really helpful to get your questions because then I know how much help to give. And well done for all your effort. Really good to know that you're all putting effort into this, trying to get it right, trying to remember which one's which. Just let me know on the email. If you're not sure how to email me, if you haven't emailed me before, you can open your school email account. You will then have an email from me about live streaming lessons. You can click reply, and I've got my school email open in front of me here, and I'm seeing your messages. We've had some good shout outs this morning. We've had some a couple of people email in their answers to little quiz questions. We've had some really good questions about, does it add up to 100%? That's a really good question. It will do, but it does vary. Each gas varies a little bit. So you can check your percentages and see if it adds up to roughly 100%. But remember, there are other gases, so it'll probably add up to a little bit less than 100% because we haven't put in water vapour, we haven't put in helium, we haven't put in some of the other gases that are mixed in the air in a really small amount. Yeah, but well done for your continued effort, Year 7. You're doing really well. And keep letting me know if you've got any questions, or if you feel like I need to put more time on the clock, let me know. Or if you feel like you're getting done, let me know. And hopefully some of you will be able to definitely get onto this, I hope. Why is air known as a mixture of elements and compounds? I've written there a diagram of molecules in air. Can you do a little diagram of just what you think the molecules might look like? And then this is really hard. Combining in this idea of boiling points and temperature and why does nitrogen come off first and why does oxygen come off first, there's a lot of challenge there. That's a really hard thing to do, so well done if you're attempting that. Can you explain the working towards again, please? Yes, I can. Right. So what is the chemical formula of these gases? Well, nitrogen is N2. That's its formula. Argon is Ar. That's its formula. A chemical formula is where we use symbols to represent the atoms. So argon has the symbol Ar. Nitrogen has the symbol N, but we write N2 because there are two nitrogen atoms bonded together in every particle. I've deliberately left oxygen blank because I'm hoping you'll remember the formula of oxygen. And I've deliberately left carbon dioxide blank because I'm hoping you'll remember the formula of that. And maybe I'll start writing in some of these percentages. Have I got the thing here? Right, so argon was 1% of the Earth's atmosphere. Carbon dioxide was 0.04%. Nitrogen was about 78%. Ooh, that's a weird 8, never mind. How many percent have we got so far? 79.04. Let's put 20 for oxygen. It shouldn't really go over 100%, but it will probably be slightly less than 100% because we haven't put water vapor in, we haven't put helium in. And then, yeah, why is air known as a mixture of elements and compounds? But yeah, if you ever need me to go back over something, sending me an email is a really good thing to do. So quite a few of you have done that this morning. Let me know where you're up to. And we have another shout out. If your name starts with C, a big shout out to Syston 7.1. A very good morning to you. I'm really glad that you're here with us on the lesson, all the way through the lesson, getting your writing done, getting your science done. A really big shout out to Syston House and to Syston 7.1. Very good morning to you. Okay, right. It's really difficult to judge the time. I'm going to start going through the answers. And if you haven't managed to write everything in, then use the answers to help you extend your work. Okay, so tick things that are correct, and please do feel really good about that and feel proud of yourself for getting answers correct. And please do write in anything you didn't quite manage to get. Here we go, right. So working towards and working at. Have I put that on there? No, I haven't. Right. So let's go back to the pointer. Right, so nitrogen was N2. And then it was 78% of the Earth's atmosphere. Oxygen is O2. Oh, excuse my pointer for a moment. And it's around 20% of the Earth's atmosphere. Argon is Ar, and it's 1% of the Earth's atmosphere. Carbon dioxide is CO2, and it is 0.04% of the Earth's atmosphere. So if you can do the chemical formula, then you can yeah, right, apologies for that. It's all just crashed on me. Not quite sure what's going on there. So we're going to have to think of someone else. Okay, right, year 7. If you're still with me, apologies for that. The whole entire thing has just crashed on me. And we're about to go through the answers. So I'm just going to have to say it out loud, okay? So if you can manage to write your answers anyway, then that's great. I wonder if I can get up a different version. Just bear with me a sec. Right, and I'm going to see if I can get a slightly different version of this lesson up, because I'm not entirely sure what just happened. So I'm quickly trying to adjust and find the answers on a different way. Bear with me a second, folks. Sorry about this. We've had no technical hitches on any of these live streams so far, and then today, all of a sudden, the whole thing crashes. Right, let me see. It is. Oh, okay. Hang on. Right. Now, can I switch this over to... Aha, here we go, right. Oh, okay, if you are still with me, well done for still being with me. Apologies for that. Let me see if I can just sort this out on the screen a little bit so it's a bit more the right size. Right, okay. Okay, folks, right, so we were having a quick look at this. So we've got, N2, nitrogen N2, 78%, oxygen O2, 20%, argon AR, 1%, carbon dioxide, CO2, 0.04%. Why is that showing something different on the screen? You're seeing something different to me. Right, so air is a mixture because it can be separated into more than one substance. In the mixture are elements and compounds. The elements are nitrogen, oxygen and argon because they're made of one type of atom, and the compounds are carbon dioxide and water because they are made of more than one type of atom bonded together. And there is my diagram there. Okay, so N2, O2, argon, carbon dioxide. Right, again, this isn't working properly. For some reason, you're seeing something different to me. Okay. It's not letting me do that. That's because I do full screen, isn't it? Right, I don't know if you can see this. Oh, here we go. Right, today I achieved. I'm really sorry about the technical hitches, folks. Apologies for this. I really don't know what happened there. Everything's gone so well in these live streams, and then today, all of a sudden, the whole thing crashing. Today I achieved. I know I haven't gone through the answers to blue, so apologies for that. Today I achieved describe because I can name the gases and their chemical formula. Today I achieved explain so I can give the percentage of the atmosphere in the air. Today I achieved use because I can explain why air is a mixture of elements and compounds. Today I achieved combine because I can explain how air can be separated by cooling it down and letting it warm up again, and they boil at different temperatures. Okay, and yeah. Well done for your work today, Year 7. I'm really sorry the technology went all weird there. I don't know what happened. Something's crashed. The school network's crashed, or the streaming software's crashed, or something's happened. But remember, you can always find these videos on our YouTube channel, both the pre-recorded version and this live stream version. Sorry that the end of the lesson went a bit wrong there. And I do hope you always feel proud of yourself at the end of these lessons for the work that you've done. It's always really good to hear from you and to know that you are putting really good effort into this work, and I always want to say really big well done. Please do remember to do the show my homework quiz for this lesson. You can go back to show my homework, click on the entry for lesson 4. There is a show my homework quiz. There is one for lesson 3 as well, so please always do remember to go back to that. Okay, will this actually move on now? But yeah, apologies for skipping the answers for blue. If I was writing an answer, I would say that air is cooled down to a liquid, then it's allowed to warm back up again, and nitrogen boils first because it's got the lowest boiling point, then oxygen boils second because it's got the next boiling point, and then they can be collected separately at different temperatures. But a very big well done to you for your effort, for your work today. And yeah, hopefully next week, Tuesday and Thursday, 10:15, we will be doing lessons 5 on Tuesday and lesson 6 on Thursday. Hopefully, fingers crossed, no more technical hitches. I really don't know what happened. But well done for joining the live stream today. Thank you for your work. Thank you for your effort. I'm going to try and fix the computer, ready for next time. And hope you have a good day. Hope you have a good week. Please stay safe at home. Hope you're all feeling okay. And big well done from me for your work, Mansfield students. Mansfield students are the best. So well done for your effort and for your work in today's lesson and in all the lessons so far. Well done, Mansfield. Let's keep it going. Thank you very much. I'm going to say goodbye. Goodbye.